Hey everybody, quick video about the beginnings of trigonometry. Alright, the definition of an angle that we're going to use is the result of rotating a ray about its endpoint. So for example, if I were to take a compass and I were to start and I were to stop anywhere, that would be an angle. Now, one thing that we see from that is that that means that an angle can be any number of degrees. A degree is the angle formed by rotating 1/360th of a circle. Why? Because we said so. Okay, the Babylonians used base 60. Maybe it has something to do with that. 1 radian, this is going to be new to some of you, is the angle formed by rotating to intercept an arc of length equal to its radius. So, I want you to think about this radius right here. And I want you to think about making an arc going along until that arc is as long as that radius. Not quite there yet, right? It's a little short if you straightened out that arc. Keep going, keep going. Let's stop there. So that angle measures 1 radian. If you see the measure of angle A equals 1, that means 1 radian. If you see the measure of angle A equals 1 degree, no points for guessing, that means it's in degrees. All right. Time for you to pause the video and think. A circle has blank radians. Okay, so if we kept extending that arc, we could go a little bit further. And maybe that's about the same length as the arc. So right here. And then we could go again. And maybe that's about the length of the arc. And then we could go again. Maybe that's about the length of the arc. And then we could go again. You know, somewhere in that neighborhood. And then we could go again. Let's say something like that. And then a little bit more. So, all told, we did 1, 2, 3, 4, 5, 6, and a bit. 6 and a bit. 2 pi. Okay, stop. Think. Why 2 pi? The radius of the circle would wrap around the circle 2 pi times, because the circumference of the circle is 2 pi r. Pretty neat, right? Some of you have been introduced to radians before. Some of you haven't. If you're thinking about degrees, you're thinking as if you're standing in the center here. And you're turning, and you're turning, and you're turning. If you're thinking about radians, you're thinking about how far would someone have to walk to get from one end of the arc to the other. In any case, don't fear, because radians are our friends. You could draw an angle from a ray with any endpoint, but we're going to draw our angles in standard position. So standard position is when you start with the initial side on the positive x-axis and you open upwards to end at some terminal side. This is actually why the quadrants are numbered in this strange order of 1, 2, 3, 4, because that's the order through which you progress through the quadrants. And we can classify angles as acute, right, obtuse, or straight. And you should definitely be able to write the inequality to describe each one of those. They would be compound inequalities in most cases. Now, sometimes we don't want to talk about the entirety of the angle. So this angle here might be something like, let's say, 210 degrees. It would certainly be a little bit more than 180. If we just want to talk about the part closest to the x-axis, we would call that a reference angle. So in this case, your reference angle would be 30. If you were to be talking about a 330 degree angle, the reference angle would be the angle that gets you back to the x-axis. So it would be this acute angle that gets you back to the x-axis. This angle, 330 degrees, would have something in common with our 210 degree angle because they have the same reference angle. Angles can be positive or negative. So take, for example, this angle that I have drawn here. Let's say, just to make things easy, that this is a 135 degree angle. That would be this angle. But I could draw an angle in the opposite direction, and in that case, my angle would be negative. Angles that open downwards are negative. So this angle as a negative angle, let's think about how that would work. This quadrant would be negative 90 degrees. This quadrant would be another negative 90, so negative 180 degrees. And then another negative 45. Add all that together and you get negative 225 degrees. So these two angles are called coterminal because they share the same initial side and they share the same terminal side. So they end in the same place and they start in the same place. They're going to have some things in common. If I were to take this angle and I were to go all the way around the circle and then go another 135, that would be 495 degrees if my math checks out. That would be another coterminal angle. So the relationship between coterminal angles is that they are related by addition or subtraction of 360 degrees, or one full way around the circle. If you need to convert between radians and degrees, remember that 360 degrees was 2 pi radians, which means that there is 1 pi radian per every 180 degrees. If you want to turn degrees into radians, you would multiply by pi and divide by 180 degrees. Remember, if something isn't labeled, it's in radians. So this is actually the angle measurement of pi radians. If you wanted to go 2 degrees, you would multiply by 180 degrees over pi radians. This is just what your science teachers or earlier math teachers would call dimensional analysis. So work out what all 4 of these would be. Something that's going to be important, and if we have a test, this will show up on it, that 18 is 18 radians, not 18 degrees. Okay, so here's a formula for arc length. I want you to try and think about this using whatever geometry skills you've learned, either in honors geometry or in geometry A, or just when you were in middle school. And I want you to try and figure out what the angle measure is in degrees of an angle that intersects an arc of 7 feet in a circle with radius 1 yard. So for example, here's roughly a circle. If this is 1 yard, then what would 7 feet, what angle would that be? And then what arc length does an angle of 6 radians cover if the radius of the circle is 6 inches? So remember, 1 radian is the distance covered by the radius once. There's a formula at the bottom which we can talk a little bit about during our Google Meet. All right, I hope that was helpful. I hope it wasn't too long. Let me know what you think. All right.